Okay, are you guys ready?
Yep.
Okay, you guys can see the screen, right?
Yep.
Okay, so you can follow this workshop, workshop, uh, like by following what I type on screen. Otherwise, you can just watch, and then if you have any problems during the whole session, just feel free to raise your questions, because this is not a very structured thing. It's just meant for a quick introduction session to what programming is in general. Can you guys hear me?
Yes.
Yep. Okay. Okay. Let's start. So I ask you guys to do install poetry, right? So in your terminal, you may want to go to a place where you want to place this. Um, we are going to create practically a new project to run some code within it. So what we are doing is we create a safe contained space where we put in our code so that whatever we write inside will not affect uh, will not it's a very contained environment. We call that virtual environment, but with the use of poetry don't really see you don't really need to you are not really aware of that because it's being handled very beautifully, in my opinion, for you. So if you see from the screen, you see this help page for starting a new project. So it's a poetry new. So I like doing this putting in this source flag because yeah, it's a personal preference, but it makes it easier when you have a lot of you are managing a larger project. But though you don't need it, but it's a habit, so you can choose to use it or not. Then after the flag, you follow by a name. So tutorial, okay, tutorial here. So you see a new package tutorial is created here. As you can see here, it's here. So you can go into the tutorial folder. So just let me know if you need me to repeat or anything. Are you guys still here?
Yeah, I'm okay.
Yep. Okay. All right. Yeah. If you guys need help or anything, just let me know. So you are in the folder now. So what we do next is we run this poetry, run Python. After a while, you should be inside this thing called Python. It's a REPL. REPL stands for read, evaluation, print, and then loop. It's it's more like an interface, like a very interactive way of doing some sort of programming where whatever you type will issue, it will return it will evaluate and return the result to you immediately. So for instance, when you are in this kind of interface, you can do simple calculation, like you can do addition between numbers, 100 plus 200, then you get 300 immediately after you press enter. Get it?
Okay.
Okay. Um. So you can do all sorts of arithmetic calculation here. For example, you can also do multiplication 2 times 3. Any sort of simple arithmetic that you can think of, it can be done here. So you can do in division here, 3 divided by 5, 0.6. You get a decimal number. Because Python is a very free-form dynamic language, so in other languages this will not be permitted because you cannot say this is not permitted. It's just that when you do this kind of operation, it will return you 0 because the type, because of the type mismatch. But type is not very enforced here because this is a dynamic language. So whenever this kind of computation happens, it will automatically convert this to the appropriate data type where the result can be better represented. So you can also do what I was trying to say is that in other languages you need to somehow force either one of this to be a decimal number, or a lot of times it requires you to have both of these numbers, the numerator and denominator, to be floating point for this decimal number in order for you to get a 0.6 here. Otherwise, in those languages, they will just return you a 0 and treat this as a integer division. So integer division is where you get the number without the remainder, the result without the remainder. So because in division you will have I don't remember the proper name for this. One is divisor, and then one is the answer. And also, if you want to get the remainder, you do this. This is how you get the remainder. We call this a modulo operator. So you can get addition, you can also get subtraction. 3 minus 5, you get negative 2. You can also do raising a number to a power, like 4 squared. You get a. What did I do? 2 to the power of 2. A. Sorry, wrong operator. This is what you get when you mix up all the languages. Yeah, this is how you do raising to a power. So this is 4 raised to the power of 2. You get 16. You can also do.
Okay.
Yeah, you can also do square root, but that is a more involved procedure where you need to. Sorry, I cannot code without Google.
Just curious, is there like a limit on the decimal? Like maybe they only show the first 5 digit or something. Is there such a limit?
Decimal point. Calculating in decimal numbers is a problem with computers because computers is not originally built for this kind of things. So they follow some kind of a precision guide. There's a precision guide ISO being published, so most of the programming languages follow it. So you asked about whether there's a limit on that. It's actually being described in the standards document that I don't really read. But if you want, the calculation to be done to certain decimal point, you can do it. Like so, you have 1 divided by 3, you get 0.3 repeating, right? You can round this up to certain point of decimal places by doing around 1 divide by 3, 4. If I remember correctly, you get 4 decimal places.
Okay. Oh,
Yep. Yeah.
what
So
is that document you mentioned just now? What is it called again?
I send it to you later because I don't quite remember the actual thing. Yeah.
Okay.
The point I was trying to say is that they follow a certain standard. So almost all the programming languages that I can think of, they follow that precision standard. So yeah, that's it lah. Okay, so back to this. I was talking about you have a lot of operations involving numbers. So numbers, with numbers, I include integers and decimal numbers, and yeah, these are the two main type of number representation. So besides doing number, we can also do represent characters. So you do this by surrounding it with a double or single quote. Usually for a character, we prefer to use a single quote, but Python is a bit flexible with it, so either one will work. So if you want to represent a word, for instance, hello, you can do it the same way. You enclose it with a single or double quote. So, like numbers, you can also do some simple operations on it. So you can concat, like joining two we call it a string because it's a string of characters. So we can concat two strings together with a plus operator. Yep. You can also, what else can you do? You can also turn this into uppercase. Uppercase. Oh, sorry. Because I'm learning another language right now, so I always forget the way to do to upper. Yeah, Python uses to upper. Right. Upper. Yep. You can turn this to uppercase. There's a lot of other things that you can do with string, but I will not be covering all of them, as this is just a very brief introduction to programming. So the point I was trying to make is that, like numbers, you can also do a lot of things with it, like joining, like taking a subset of the characters out, etc., etc. So now we have talked about numbers and characters and a bunch of characters we call string. Now we will attempt to print them. So in this environment, whenever you hit enter, you get the result. But it is not the case when you run it as a program outside of this environment. So in an actual program, when we need to present things or a result of computation to the screen, we use a print command, or we call this a function actually. So function is called by, first you write out the name of the function, then you follow by a pair of parentheses. So inside the parentheses is what you want to print to the screen. So for example, I can print 1 plus 1 equal 2. Now, because of we are inside this REPL, so you see the result. It doesn't look very different from what we did just now, but actually, when you run this as a when you run your code as a program outside of REPL, if you don't print your result, you will not see it on the screen. So this is one of the way we put things to the screen or present a result of a computation to other people, right? So you can print numbers, you can also print characters, you can also print a bunch of characters we call string. Hello world. So far we cover doing some operations with number, string, and we talked about how to print stuff. Okay, so is there any question on this?
Yes, I got one question. Why is it when you print number, you don't need the open and close, the, what is it called?
The quotes?
Yeah, the codes, but when you use number, you don't need, you use word, you need. So
Yeah, this goes back to when you do numbers, you don't put quotes around them, right? But if you put in just a character, it gives you an error, because if you don't enclose characters or a bunch of characters, a string with quotes, single or double quotes, Python will treat it differently, because alphabets without with that is or that are not enclosed by string, they have special meaning. So they can they can be either some language construct that you will see later, or there will be a name that represent other things. This is something that I'll talk next. Yep. So whenever you want to represent string or character, which in Python they are actually treated the same, you need to enclose them with single or double quotation marks. Right? So now we talk about doing a lot of computation operations on numbers, strings, characters, right? So oftentimes doing this operation is just a starting. Like, you need to do a lot more than just one simple computation. So in those cases, you may want to store the result of intermediate step into something which you can refer to it later. So this is what we call an assignment. And when we do assignment, we use a symbol that you might think it has some sort of similarity to mathematics. So let me show you how it looks like first. A number equals to 10. So when you read this for the first time, you might think this is a mathematical representation of something. So you might think you can do something like y equals to mx plus c, a very well-known straight line formula, right? So there are two things that you want to know first. So because like I demonstrated here, you can use more than a character to represent things. So whenever you need to do multiplication, you need to explicitly add a multiplication symbol operator. You need to add the operator here between two different things. And if I put this into the REPL, I get an error because unlike mathematics, you need to have everything on the right hand side defined. So this happens. So in mathematics, we usually have, okay, you already have y, you have x, you have c. What is m? This is not how it's done in programming world. When you do this kind of programming, you need to ensure everything on the right hand side is defined. So if you want, so you cannot do like find m when you have y, x, and c. What you can do is, if you really want that, you need to do your own homework. That if you want m, you will need to do this. So you will have y minus c divided by x. Don't forget your parenthesis. The parenthesis works like mathematics, so it has higher precedence. So this part will be executed first, and this will be calculated later. So you need to do this if you need to find m. But of course, since we don't have y, we don't have c, we don't have x, this will throw us an error also. So remember, whenever you want to assign something to a name, everything on the right hand side must be defined. So what is the use of this, you may ask? So just now I just stored a value 10 into this a name called a number. You can also put in result of some sort of computation. So you can do my lucky number, maybe 10 plus 20 plus 7. It can also store the result of computation or an operation, a list of operation, into a name. So in the future, if I want to refer to this, I can simply just refer to it by the name. You will get the result straight away. Otherwise, we'll be repeating this portion of code everywhere. So assignment is just something that will store everything, whatever that's on the right hand side of the assignment symbol, to a name on the left hand side. Does that make any sense to you all?
Yeah. Just one question. Why do you need the underscore?
Yep. Like I said just now, you can have more than a character as a name. So if you want, because if you don't do this, you will have my lucky number equals to 10 plus 20 plus 7. Because if you don't include underscore here, this will be seen as 3 different names.
Oh, okay.
Yep. So you join it with, usually we join it with an underscore. This is one way of doing this, or we join them together. This is what we call a camel case. 10 plus 20 plus 7. In a lot of languages, they don't allow number to be in the first place of a name, but you can include number in the middle or at the end. So you can do my lucky number 10 plus 20 plus 7. This will work also when the number is in the middle or at the end, but not the first. But having an underscore at the first in the beginning of a name is also accepted. What is not accepted is a dash or other special characters. You cannot use quotation marks for obvious reason, because this will make everyone confused, because because this is used to represent a string or a character. So you cannot use a quotation mark or single or double quotation mark. Also, a quick note on the quotation mark, you cannot do this. You cannot do single quotation mark, then you do a double quotation mark. This will not work. They must be matching. They must match.
So either all must be single or all must be double.
Yes.
Okay.
So are we clear about assignment? Any more questions on assigning things to a name? If no, then we will proceed to the next part. So now we know how to assign things to a name. We know how to assign a result of a computation to a name. So we now attempt to do something with it. So this is what we call branching, where we do something based on a decision. So the general form, it looks like this. Is an if statement. It can be other type of statement in other languages, but since we are in Python, so the most common way to do a branching is through an if statement. So we have if, then we need something to decide whether we do the first case or do the second case, followed by a colon. We have the first part of this is a placeholder, so we call this a condition. Then we have else, second part. Right. So what a condition is something to decide whether we want to execute whatever that is in the first part or whatever that's in the second part. So what I mean here is that now I need to introduce you to another type of data. So far we talk about numbers, we talk about characters, we talk about strings, where these two actually are treated almost the same in Python. Besides these three different types of, we call this data, we also have a kind of data that only represents whether a thing is true or false. So we have this, they are represented as true or false with T and F capitalized. So in other words, all these things, all these words that we've seen here cannot be used as name to hold other values. So we cannot do assignments with the name being set to this. We cannot use if, we cannot use else, we cannot use true, you cannot use false as name to assignment. Because when you do this, you get an error. You cannot assign things. You cannot assign values to things that already have certain kind of meaning in Python, which we call keywords here. So keep this in mind. Don't assign values to words, to names that already has some kind of meaning in Python. So we've just seen true and false. Now we have if and else. Okay. So the reason I talk about this true and false here, they are called a boolean, however you pronounce this, is that this condition is expecting something that returns a true or a false. In other words, what makes this kind of values? Of course, you can just put in if true, then this part will execute, or you can put if false, this part will execute. But this has no meaning, right? Because if you already know the answer to true or false, you might as well just keep writing this part, right? So what you can do to get this kind of value is, one of the way is to by comparing two things. Like we see whether 2 is equal to 3, false. 2 is equal to 2, true. Or because this looks very stupid, right? So usually we compare the result of a computation to another or to a value. So we want to know if 10 plus 7 is equals to 17. This is how we usually use this. So this is a comparison operator where it compares whatever that's on the left hand side to whatever that's on the right hand side. So when you have equal, you also have greater or equal to 10, let's say. You also have just greater, and of course you have the other way around, greater or equal to or greater. And of course there's one more that I didn't cover, 10 plus 7 not equal to 17. So usually in mathematics we write a fat equal sign, then we do a strike in between the two lines, isn't it? So because we cannot easily type that character in the through our keyboard, so this is how we represent non-equality.
So that is exclamation mark, is it?
It's an exclamation mark. Yes.
Oh, okay.
This is what we do when we want to check if two things are not equivalent. So we can also do similar things with characters or string. We can do hello world to see if they are equal. Hello equals true. Okay, now we want to apply. We have the first piece of the puzzle, so we can do this. If 10 plus 7 equals to like 12. So we have the first part. Now we now need to figure out what to put in this here. This part only executes when the condition is returning true. So if, let's say my condition here is true, I want to print I am happy. And then if this doesn't return true, I would want to print I am sad. This is how you do it. So because this is not obviously not 12, so it goes to this part of the construct and print I am sad here. So notice there's a space here. There's also a space here. And there's a colon here and also another colon here. This is a requirement of the syntax, so there's no reason, there's no explanation to this, just follow it. There's explanation, but I don't want to talk about it now. All you need to remember is you remember to put in a space here. If you put in two spaces, then if you put in two spaces here, then do the same here also. Don't put two spaces here, then put three spaces here, because Python is very strict about indentation, because this is what you call indentation, because indentation here in Python, they actually mean something. So indentation here means this is belonging to this case. If this is true, then the indentation here, it means this thing here, it belongs to this case else, right? So, before I continue, is there any question?
The else no need to space, only print needs to space, right?
Sorry?
Else doesn't have to put space before the word. Right?
No. The reason
only
we
print
don't, the reason we didn't put a space before is we want to indicate whatever that is in the true case is already ended. Now we need to talk about whenever the condition is false. We're going to talk about the second case of this condition.
Oh, okay. All right.
Right. Okay. Is there any problem?
No, I'm good.
Alright, okay. So now we see a branching of the operation into two different branch. Is like you read interactive story, like you reach a branching point. So if you want to save this person, you go to page 1, and then you want to save another person, you go to another page. So this emulates that kind of behavior, but you can also have more than two cases to handle. So for instance, if I see an odd number, I do this. If I see an even number, I do that. But if the number is exactly 100, I want to do something else. So here we have three different cases, right? So what we can do here is we can start handling the most specific thing first, where the number is, let's assign this to a number, let's say it's 42. So we want to check whether this number is 100 first, because this is the most specific one among the other two. So we will say a number is equal to 100. Print I score an A. Okay, then we want to handle the second one. So unlike in this case we only have two branches. Now we have three. So we cannot use else. Otherwise, there's no way to represent the other case, right? So what we do here is we do an else if. Right? An else, then we check another condition. If a number equals with a remainder of 2 equals 0. I mean, a number that divides by 2 with a remainder of 0. This is the meaning of this one, remember? This is how we get the remainder of division. So this is basically the meaning of this sentence. But in Python, yeah, because programmers are lazy, so instead of typing else if, because this is very long, like 2 characters extra, we just remove these 2 characters. We call that an elif. It's actually else if. Okay, and then we can print another thing. Or this even number. And then if a number is not 100, is not even, then it must be odd. So you can just straight away handle this as else, because there's no way a number there's a way the number can be other things, but in this case the number cannot be an even number anymore, right? So we can just ignore the condition part and then directly print the odd number as, yeah, this is 42. That means it goes into this condition. another thing I will talk about this branching part here is that you can actually put in multiple things inside this, what we call blocks here. So far I've only inserted one thing in here, right? You actually can put in multiple things inside that. So we can put a number equals to 100. Hey, what did I do wrong? Yeah, this is a very major, very common problem where you mistake equal operator as an assignment. So yeah, take note here. So when number is equal to 100, you can print I am happy. You can also do other stuff, print 1 plus 1, or do other things else. So it will work, it will just execute this one after another. I should have put more things in this block, but you should get the idea lah. So another thing that I want to talk about here is something that I forgot just now. Whatever that is that begins with a hash mark here is something that we call a comment. So the comment is not meant for the computer to see. It's not meant for Python to see. It's actually meant for yourself. So you can use it as a note to self thing. So to explain what you are going to do next, what happened, like describe what you are about to do in the code. Print I am happy if score is 100. You can do this before you write a long piece of code to explain what you are about to do with the code. So you do that by putting the notes beginning with a hash mark here. We call that a pound sign usually. Yep. So this is very much what branching does in programming lah. So any problems any questions? Oops. A what signature? A hash statement? What do you mean by signature? Oh, we call this a comment. This is a comment.
I just want to find out because the latest example you gave, if a number equals to 100, print I am happy, print 1 plus 1. So if the number is really true, how does it appear the result?
Sure, I can show you. Okay, let's reassign the value of number to 100, right? So number equal to 100. What did I do? So print I am happy. Print 1 plus 1 else print I am sad. It will just do everything inside it one line after another.
Oh, okay.
So far we do everything, every line means one thing, right? So if you want to put these two in one line, which we usually don't, what you can do is you do this print I am happy. You separate two different things, two different operations with a semicolon. Print 1 plus 1. This will work also. The meaning of the semicolon is like you separate these two things into two different two separate commands or operations.
Okay.
Alright.
One thing, sorry, I'm not very clear on else if. Can you explain one more time?
Sure, no worries. Just now we see here, when we only have if and else, we only branch once, like so we only have at most two branches, right? So we can only handle if this statement here, this condition here is true or false. But in sometimes we have cases where we want to handle three different outcomes. Like we have three different outcomes for a certain decision. So when we have three kind of outcomes, we usually have more than one kind of condition that decides what the outcome is, right? So this is where we put the condition. This is the first condition. If it is true, then we don't care about other cases. So if this is false, now we have to consider the other conditions that where to, because if we don't have this else if, it will be everything that is not 100, and then we cannot check whether a number is odd or even in this case. So if we want to check a number is odd or even, we need to do another check here, else if, then we put another condition here. Then the else here will be both this a number equals to 100 and a number is even. These two conditions are false, then we go to this print odd number. Yep.
Okay.
All right.
Okay.
Another thing that I want to talk about briefly about if and else. So say we have a number equal assign 100 to this. If number is 2, okay. Alright. We can also, instead of the else if just now, we can also put in another if statement inside the outcome of inside the outcome part of the code. So just now we were doing this ELIF, right? So instead of that, we can also do this. We can also write a new if statement into the outcome as the outcome. So we can also check number is 100. Notice when I am inside, so I put in some spaces here, right? So if I want to write the outcome of this if statement, I need to indent my code another one level further. So another same amount of spaces. In this case, I use a tab. To indicate that this outcome belongs to this condition instead of the previous one, right? So if I have an else, it also has to be indented one time to indicate it belongs to this if statement, not this one.
Okay.
Right? Print another thing. Okay. In Python, you can also have cases where you only have you only do things when the condition is true. Number is 100. And then you just leave it as is. You don't need to. The else part is optional, right? You can also do if a number is even. Sorry, it's even. That is 0. You can also leave it. You can also do an else if a number and then just leave it. You don't always need to implement an else part of an if statement. You can always leave it as is, just an if or at most another else if, right? And also another thing is that this if statement block, this block of if statement, it can happen also inside this portion when the condition is true also. Okay. Okay. If a number is 100, print do this. Do this. And you can also put in things to be executed before and after the nested if statement. You can also do another check. Number is even. Sorry. Of course, in this case, this part is not going to be executed because 100 is obviously an even number. But yeah, so it will still execute one after another. And you need to be very careful about the indentation. Whatever that is belonging to this condition is one level of indentation. This belongs to this condition, so it has to be 2 levels of indentation. You can also do things after this if statement. So for instance, number is 100. If a number is even number, you can also do after the if statement that I mentioned just now, right? So you notice that because this happened first, so this will be executed, then it will be followed by this statement here, this print command, this statement, this belongs to this condition because this only has one level of indentation, so this belongs to this condition. However, this one has 2 levels of indentation, so this belongs to this condition. So if let's say this is false, what did I do wrong? Okay, so in this case, this is not printed because this belongs to this condition and this condition is false. So this line is not being executed. Okay? So this pretty much concludes the branching part of programming. So what you need to remember is what is a branching. Branching is just deciding what to do depending on a condition. And then another thing that you see is that a complex, uh, comparatively, relatively more complex kind of structure can be also put inside another one. We call this a nesting. So we are nesting another if statement into an if statement. This is what we call nesting. We nest an if instruction inside another if. Right? So this concludes branching. So now we know what to do when we know. Now we know that we can do different things when we have a condition, like when we can decide how to treat, how to perform certain tasks when the condition is different for each cases. So now we talk about repetitions. We want to repeatedly do things, similar things, like multiple times without having to like do it manually. Like if I want to print hello world, I don't want to write this 10 times in a row, right? Because as I told you just now, programmers are lazy. So because if you don't like to type this else if, there's no way we want to like repeat the same task like 10 times, 20 times, 100 times. There's no way we want to do that. So there's this construct we call repetitions or loops. So what you can do with this is that you can make it to repeatedly do similar things. You can also make it to do the same thing. Like, let me show you how. Let's say I want to do something 10 times. So I have a counter. First I have a counter. Then I, similarly to if statement, when I write a loop, we call this a loop, I need a condition also. So in this case, I want to do this task 10 times, right? So as long as the counter remains less than 10, I want to continue doing this. I want to continue to print hello world. Hey. Spelling error. There's one thing I didn't do. Okay. I have counter set to 0. While counter and print hello world. This is what I typed just now, right? One thing I forgot just now is if I leave it as is right now, the counter will always be 0, and this will be true forever, and hence this will continue indefinitely. So I will have a full page of hello world, and it will never stop until I force it to stop. So I want this to be done exactly 10 times. What I need to do is that there's one thing in assignment that I didn't tell you, is that you can do a cheat. A cheat like this is not a cheat, but it's because this is not mathematics, we are allowed to do this. So what happens here is that we have counter is currently 0. We plus a 1 to it. Then we assign this as a new value to the counter. Because you might have already noticed that we can keep on redefining, reassigning values to a name multiple times whenever we like. So this is just a variation to it. It's just that the new value of this counter is based on what it had before. So in this case, what we are doing here is that the previous value of counter is being incremented by 1. We do this operation, then we assign this as a new value of the counter. Alright? So just how you saw when I did not include this line, the hello world will just like immediately like fill up my screen. So this case, it should only happen 10 times. Right? You guys still with me?
I don't understand how it come out 10 times and
Alright. You do you understand this line already?
this one you change the counter that you set, because earlier you set 0, so you change that definition into +1.
Right? Alright. So after this line, so after the first run, this one becomes 1, right? Counter is 1, right? Okay, what this this block of code does is that after this is executed, it goes back to check the condition again. So now that counter is 1, it is still less than 10, and it's true because this condition is still true. So it will continue to run this. Will continue to
How
run
did
this.
you set it to just run 10 times?
Yeah, because of this condition here. This is condition of
okay.
the operation, and this is while is a type of loop where we want to perform whatever that is defined inside it, whatever there is one level indented, as long as the condition is true. Right?
Okay.
So we have counter initially is 0. So because 0 is less than 10, so we will do whatever that's defined inside it. So we will print hello world. Then we'll increment the value of counter by 1. After this is done, we go back and check the condition again. 1 is still less than 10. Then we continue printing the second hello world. Then we increment the counter again. Then this goes on and on and on until the counter is 10. When the counter is 10, 10 is not less than 10. This finally fails, so it will exit this code here, this block of code here. So this only happens exactly 10 times here. This is why it only happens exactly 10 times. So if you omit this line, you already saw the outcome of that. It will immediately go on and on indefinitely, because this is always true, because the value of counter is never changed, right? Of course, because I say this is a condition, right? You can also write code that never runs like this. Then this will never ever run. Hey, I forgot this. Yeah, this will never ever run. Print all over. Yeah, as just like, because false is besides getting the false true and false true comparison or whatever, to this comparison non-equality whatever, you can also still use this as is. So what happens here is that if you want things to run indefinitely, usually with good reason, you can just do this. then it will run indefinitely. So this is a type of repetition, looping. So is there any question on this?
I'm a bit lost just now. Sorry. I do understand how it will run indefinitely, like the whole page of the part, because you say zero, sorry, if it's less than 100, so even if it's zero or if it's plus one, it's still less than 100. I don't know why is it different.
Oh, okay. Let's restart again. Okay, let's have a counter 0. Alright, now we have while counter, just now we said 10, right? Okay, we print hello world. Okay, now we do not write the line that updates the value of counter, right? So when we execute this, it will run indefinitely because this is always true, because you don't because we don't update the value of counter ever, right? If I press enter right now, it will still go on forever and ever, because counter is always equal to 0, and hence it's always less than 10.
Oh, okay. I think I understand what you mean. Let me see if I understand correctly. You're saying that if I plus one, so when it loop again, you like one plus one becomes two, and two plus one becomes three, until they reach 10 and it becomes false. That's why it didn't run continuously.
Yep.
Does that? Oh, okay,
Yes.
okay. All right.
Counter equals to counter plus 1. You run 10 times, because whenever the last statement is evaluated, it will go back to the beginning and check the condition again. This is how a loop works. This is how looping works. It will always go back to the condition and check and evaluate whether the condition is still true. If it's true, then we'll go on and on and on and on, right? All right.
Okay, okay, all right.
Okay. Just now no worries. Okay, just now we talked about we can do operations with numbers, and strings, characters, right? And actually, we can also do operations on true and false. So, if you have learned logic gates in Form 5 physics, or if you've done some sort of mathematics in post high school, you will learn about logical expressions where you see a lot of and true and false, true or false kind of thing. In Python, you can also do that. And in fact, I just demonstrated. So when you have this kind of thing, you can also apply this to the condition portion of if and while statement itself. So just now I have counter equals to 0, while counter equals to 10, right? Just I stop here, right? So what if I also want the counter to stop at I want this loop to stop at exactly 3, right? I can also do this. Not counter equal 3, right? for remember to increment the value of counter. Hey, I must have done something very wrong. Hey. Wait, I want. Well, let's start with this. My brain is not functioning now. Hello world. Hey! Counter equals 0. This is what happens when you don't prepare beforehand. Counter. Not counter equal to 3. When it's not equal to 3, discontinue. Counter plus 1. Yep. This one works. So what we have is, I just introduce a new one. Not is an operator that negates this this whatever that's after it. So this is because 0 when counter is 0, this is true. When I put a not operator in front of it, it becomes a false. So whenever the counter is 3, this whole condition is false, hence it exits the loop here. Right? So far so good. Huh? Hey, counter needs to be 0 first. Yep. So just now I introduced this not operator. Now I'm introducing and actually all works the same also. So we have not. So when you have and, you first need to evaluate this part on the left hand side, then we evaluate this on the right hand side. So let's go through it one by like manually. So we have counter equals when counter is 0. This one we will first see 0 is not equal to 3, but we have a not in front of it, so not false and counter less than 0. Yes, this is true. And then we evaluate this false, not false, so this is true and true. So when counter is 0, true and true, evaluates to true. So it will print the first hello world because this condition is true, right? Now counter is 1. 1. Similarly, this is still not false, and it is still less than 0. So like just now, it's returning a true. So it will print the second hello world, and then the counter increments. Okay, now it gets interesting. Not yet. Still the same outcome. And true. Get true and true. Get another true here. And now our counter is already 3 after printing the hello world. Counter is now 3, right? Counter is 3. We don't talk about not first. Okay, now counter is 3. So this is finally true. And then you have true because it's still less than 10, right? So we have, when we evaluate this part, not true, not true, that means it's false, and true. When I have a false and a true, it evaluates to a false, because for this to be true, both sides of this AND operator must be true. This is a very basic logical evaluation. So now that when counter is 3, the condition is false, it will finally exit this loop here. Right? Get it? Yeah, so AND and OR, they chain up conditions together, and is an operator, is operations that you can do with this Boolean values. You can do this however you like. So this true and false can be taken in this form or this form or whatever form. Anything that can be evaluated to true and false can be chained up together with AND and OR. Of course, you can also negate the result with a NOT operator here. Okay? So there's another type. So now we talk about repetitions, and there's another type of repetition that I want to show. But before that, I want to introduce a new type of data, which is just now we saw a bunch of characters. We call it as a string, right? We have this hello. So we call a bunch of characters as string. But what if we have a bunch of something, anything? It can be a bunch of Boolean values, a bunch of numbers, or even a bunch of characters, bunch of strings. We can actually represent them in a list, what we call a list. 1, 2, 3, 4, 5. Or hello world, I am superhero. Right? And because Python is a dynamic language, there's another thing that you can do with this. You can mix up numbers, characters, strings, Boolean values, or even another string inside. Even another list inside. This is what we call a list. A list is something that is enclosed within a square bracket, and then each element is separated by a comma. Okay? So what is this going to do with repetitions, you may ask, right? So let's say we have 1, 2, 3, 4, 5, and we assign it to a list. Okay? We can also do things to a list in this way. So I want to introduce a new thing, which we call a for loop. So what you can do for for is that for every element inside a list, I want to do something about it. So I can do element in a list, print the element. Then it will print out everything inside one after another in sequence. See? This occurred first, so it will be printed first. Occurred in the second place, printed the second one as a second value, third value, fourth value, the fifth value. This is another form of repetition. Of course, you can still do this in this while loop, but it is done slightly differently. So we know there are 5 things, right? So we have counter equals 0. We have while counter. We want this to be done exactly 5 times. Print a list counter. Then finally, remember, you need to increment the counter. Okay, so this is new to you guys. A square bracket and then enclosing a number inside a square bracket means you are accessing an element inside a list, right? So there's one weird thing that we programmers do is that we like to count from the number of 0. You may have already noticed just now I started the counter from 0. Now when we refer to elements inside a list, we start counting by 0 also. See, this is the 0th element. This is the first element, second element, third element, fourth element. Right? Any question on this one?
Okay.
Right? So these two are mostly equivalent to each other. It's just that if we write it as a for loop, it just looks a little bit nicer. It's just a shorter way to represent almost the same thing. So because of this, for loop is very much friendly to this a bunch of thing kind of construct. It is always used for with things that is put together like a string, but like a list here. So just now I told you that you can also do this nesting. We call this a nesting. Whenever we put things inside another, we call it a nesting. We nest things inside. We can also do this. we can just print everything out one after another. And like if statement just now, we can also nest loops inside another loop, or we can also write if statement inside another loop also. So for instance, we have a list 1, 2, 3, 4, 5. We can do while, sorry, this is easier, element in a list. We can write an if statement here. Element is even, print the number. Then it will not print all because not all of them is an even number. Even though we go through all of them, but because there's only one print statement, and this only executes when this condition is true, so it's only printed 2 times. It only prints out all the even numbers. Okay. If you really want to, you can also write another loop inside a loop here. So for instance, when it is useful, I will show you here. When you have a list of list, like list of lists, right? 1, 2, 3, 4, 5, 6. So you have 2 lists inside a list. So if you want to print everything out, if you want to print everything out, each takes 1 line. So what you can do is for list in sub list in a list, for element in sub list, print element. Then it will print everything sequentially, each taking 1 line. So what happens here is that when we do the outer one, the outer loop, when we go through the first time, it will take this sublist, right? So now that this sublist equals to 1, 2, 3, right? So we can write another loop to access each of the element within this sublist. So this should look familiar to you, as this is exactly the same thing that we did just now. This is exactly the same thing we did just now. It's just that the sublist here means this one, the first element of the outer list, right? This is just to show you that you can write a nested loop inside a loop. Of course, you can test this indefinitely if you have a structure of data that has a indefinitely nested list. But usually we do this like 2 or 3 levels. More than that, then you need to figure out what is wrong with the design of your program lah. Yep.
Okay, it's just curious. Actually, why does it list down? Is it because you put print element?
Sorry?
What does print element means? You bracket the element. Does that mean print element means list down all the
alright.
words?
When we write the outer part of the list, the loop, so this one refers to the whole thing. And this whole thing is a big list containing 2 smaller lists. You see? You have one list here and another list here. The first list is 1, 2, 3. Second is 4, 5, 6, right? So if we have a very normal one layer list, right? It's just when we do this, an element we don't see this an element. Let's name it as anything. For A in a list, so A means one each of this, right? So if you apply the same thing here, I name each element of the outer list, this one, the big one, as a sublist. So sublist means either this or this, the inner smaller list, right? Okay, now that we have sublist defined and we want to loop through the elements inside the sublist, we write another loop. This is where we nest the loop. So you see, we always put for something in a list. So when you have for in statement, we put the list on the right hand side towards the end, before the colon. So in this case, sublist is a nested list, right? So we put in here. Okay? Get it? So when we have it here, that means we can now access each individual element inside the list, inside this sublist, this smaller list. And I just happen to name it as element. So print element here means print each of the element inside this sublist. So once this is done, once we're done with the first one, we go back to the loop and then we fetch the second sublist. Then we repeat the process. We loop through every element inside the second sublist. Then we print each element one in their own line. Alright? Hey. Get it?
Oh, okay.
Yeah, also, since we can nest an if statement here, actually we can also put a for loop inside another if statement. Do I need to show you? List is 1, 2, 3, 4, 5. If true for element in a list, print element. Yep, this will work. Just like how we did it here. Okay? And as I said, for is just a nicer version of while, so you can also write the equivalent while statement here. Alright? Okay. Just now, I told you about operations between numbers, between strings or characters. Actually, you can also do operation with string to the list. And one of the things you can do to a list is you can know the length of the list. How do you do that? You just throw the list into a function we call length. 1, 2, 3, 4, 5. Then you get the length of the the list. So what you can do here with it is that, remember we had a counter equal to 0. Then we say counter equals less than 5. Then we print a list counter thing. Remember this? Hey, what did I do wrong? Okay. Counter equal less than 5. A list equal to 1, 2, 3, 4. Okay. Counter equals 0. Wow. Counter less than 5. Print a list counter plus 1. Right, it will print out the element. And I just told you that you can actually know the length of a list by using this. By throwing the list into a function called len. So instead of writing a 5 here to explicitly tell the loop to stop after 5 times, I can do this. 4, 5, counter, 0, counter, len, a list. Counter, counter plus 1. Yep. So passing something into a function is also considered as an operation done to something. So I can also find out how long a bunch of characters a string is. Like you can count how long this hello is a five character string. Yeah, basically there's also, like, for instance, you can find out the absolute value of a -1. We return a 1. This is also considered as an operation done to the data. Because the reason I talk about this is because I want to introduce code reuse. Like I mentioned just now when I talk about repetition, programmers are lazy. So if you have a bunch of things that you keep on repeating, like for instance, I always print hello followed by print I am happy. If I always do this, or if I always, like, throughout this whole thing, you always see me test whether a number is even, right? How to test a number is even? Number is even. 42 divided by 2 equals 0. You often see me test whether a given number is even, right? So if you don't get sick by now, I already am getting very, very sick typing this out all the time. So what we have here is actually a way to define what we call a function. So for instance, we can define the test to see if a number is even by writing a function, which in this case we call is even. and this function requires a number. And then we can do some computation inside the function, and then we return the value, the result. So computation is like what we did just now. We can do like number plus 1, then we can choose to print it, alright, whatever, or we can save the result number, the modulo 2 equals 0. Then in the end, we return the result by typing a return followed by a value. Right? In this case, we already calculated the value result. And or if we do not already have this line, we can also do this directly. 2 equals 0. Whatever that happens after return is evaluated and returned to whoever who calls it. Okay? So in this case, we just settle with this result. Actually, I would like to redefine this. Return num2. Alright. Calling a function should not be very foreign to you because you have already seen me doing this multiple times. Calling a function is just, in this case, we are calling is even. We want to test if 42 is even. There we get the result. It takes in a number, in this case of 42. Then 42 is tested to see if it is even here. So in future, instead of typing number modulo 2 equals 0 in an if statement, if a while statement, whatever, I could just do is even a number. So you might say, oh, this does not save me any keystrokes because these two, like, they have the same amount of characters, right? But in reality, if you keep on typing this, and you may have already observed that I always make mistake when I type things. So giving an operation, certain operations a name, it's much easier to remember and reduce the risk of screwing up. So it's always a good idea to put things that you always do inside what we call a function. This is something that is relatively more similar to what you see as a function in mathematics. It's just that this is what we do in the programming world. Okay? Any questions on this? It's practically just a bunch of things that you always do, but you packaged it inside a function. That's it.
Okay.
So, besides, you can also write functions that doesn't return anything. Okay? For instance, you can write a function that returns an essay, and then you can also write functions that does not take in any parameters. So you can happily type an essay or poem, hello world, print some whatever forum, some folder sheet net, then print my day is good, etc. etc. When you're happy, finish it, then you can call it wherever you like. Inside a loop, inside if statement, inside as a condition of if statement, whatever. You can just put it there. As long as it fits. If it is returning a boolean number, a boolean value, you can put it inside a condition. If it's a number, you can use it inside as a part of a condition or something. Think of programming like you can think of programming as building Legos. As long as it fits, then it should fit. If you think it fits, when I mean it fits like, so for instance, you have a while statement. Just like I told you, this condition part. It always expect a boolean value, whether it's true or false. If your function is always returning a true or false, it can be called here. So I can always, like for instance, I have an is even here. It's always returning a true or false as long as I throw in a number inside it. Let's not do a while. Let's do an if is even 42. Print hello world. It will work. It's like a Lego. As long as whatever that you return is matching the expectation of a component or place, then it will work. It's just like Lego, building Legos. As long as it fits, it should work. So this practically conclude the very majority part of this workshop. If you have any question, do you guys have any question on this? Because
I think I understand that. But to replicate it, I don't think I will be able to remember so much.
It's okay, because in the end, all I want you to remember is just there are only 4 things inside a very basic programming. There are 4 basic concepts in programming that I want you to remember. The first thing is the operating on things and assigning the result into something to a name, a number, 10, 12, assigning, plus 7, assigning an operation. First thing. The second thing that I wanted you to remember is branching, if statement, if, else if, etc. The third thing that I wanted you to remember is looping, the while loop and the for loop. Alright? The fourth thing is to repeat whatever that you want to do. Define function. These are the 4 very, very basic things that you need to know before you start learning a language. Because in every language, they have a variation of these 4 things, but maybe they use a different name or a different way of doing it, or they have a different form. They might not even be called an if, else, or they may be called a switch, they may be called a match, or something that we call pattern matching is also a kind of branching. And in other language, we might not have while, we might not have for, we might have some sort of recursion that do similar things like repeatedly. yeah, but the basic concept is just that you can do things repeatedly in programming. Like you don't have to like repeat the same thing over and over again by copy and pasting the same code. You can just write a good kind of loop to iterate, and then lastly you can do functions. If you if you want to repeat certain things that you keep on doing in different parts of the code, like you can package everything inside a function. That's it. These are the four major things that you can do with programming. And of course, there are a lot more things that were invented to make your life easier, or to make it easier to manage a larger scale project. So you might have heard someone throw like object oriented. You might hear people talk about functional programming. You might hear people talk about other things. But in the end, these are the only four things that really matters. All the new things that you hear people invent, they are just a variation of these four things. That's it.
Okay.
Alright. So now we want to see what happens when we do not have REPL. So the reason I wanted you guys to have an editor is because I want to show you how to write program that does not live inside the REPL. So this is where the use of editor starts. So I wanted you guys to install an editor. Any editor is fine. I'm not teaching you how to use an editor, as long as it can type things, you can write things without formatting. It is good enough for this workshop. That's it. I'm not starting a war on what kind of tool you want to use, you can use, you like to use, you don't like to use, why it's good, why it's bad. It doesn't matter. As long as you can write things in it without formatting, it's good enough. So in this case, I'm using VS Code. Alright, remember just now I created a new project with Poetry, right? So if I start a new project with Poetry, new, and with this source flag, I will have this source folder. So usually that's where I put my code, but in this case, I'm putting a code at the root folder here. So what I do is type the command to your favorite editor, then type a file name .py to indicate this is a Python script. Alright, open it up, and then you can start typing in some code that lives outside of the REPL. So if you remember, we don't really need to use print statement just now, because whatever that we type in the REPL and press enter, the result will be printed out regardless whether you have a print statement or not. However, now that we are outside of REPL, if you don't issue a print statement, if you don't call the print function, nothing will appear. So you can do all the calculations you like. 2 plus 2, 3 plus 3. You can do everything, whatever you like. But if you run it, you run it by typing poetry run Python followed by the name of the file. Nothing will be printed out if you don't issue a print statement. So if you want all this cool calculation that you spend nights like doing, you need to remember to print it out. Otherwise, no one is going to see the result of your calculation. Remember to always print. And practically that's it. That's how you start writing a program. So I want to kind of conclude this by writing a very famous interview test quiz to show you how writing code is in real life. This is what we call a FizzBuzz test. I probably don't remember exactly how it's done, but the point is you are given a number, a range of number 1 to 50, a list of number 1 to 50, and then for number that are divisible by 3, print fizz. And then for numbers that are divisible by 5, we print buzz. For numbers that are divisible by both 3 and 5, print fizz and buzz. Okay, this is the requirement of this program. So how you do this? So I told you we can have a list by defining 1, 2, 3, 4. But there's no way I'm going to type 50 numbers. So in Python, there's a function we call arrange. So we'll type 50. What this does is it returns something like a list that contains a number from 0 up to 50, but it's not inclusive, so it only gets to 49. Okay? Alright. Okay, that's the start of this. Okay, now that we have a list, we want to do a loop to the every number in the list. So, like we saw just now, we can do for element in a list. Okay. Okay, we want to see if this code works first. So we can just print element. Repeat the command just now. Now we see all the numbers are being printed out. You don't really have to write the whole program in one go. You can do it like in stages to track your progress. So you don't have to be very pressured into writing a whole program like in one go. That's impossible. Maybe that's possible, but it's not for me. It's impossible for me to do that in one shot. So I usually just make small progresses and then I run it to see if I'm on the right track, then I continue. If I don't, it's often early enough for me to make necessary changes. Alright, so we stop at printing the numbers. Now we want to run some branching to the numbers. Okay, let's handle the first case. First, if element is divisible by 3, that means the remainder is always 0. Then we want to print fizz, right? So to be sure, let's print element first so we can check. Alright. So according to our code, we first print the number, and if the number is divisible by 3, print a fizz. Okay, so we see 21 is followed by fizz. So that means 21 is divisible by 3, which is true. So we also see all the multiples of 3 is followed by a fizz. Alright. Then we handle the second case. else if element of 5 equals 0. We want to check if divisible by 5. Print bus. Then we run it again. Okay. I must have deleted the. We need to keep this. Alright. We see all the numbers that are divisible by 5 gives a bus. See, 35 turns a bus. If you if you read properly, then you should know that this is a problem because 30 is also divisible by 5, but there's no bus, right? So that means the condition is not written properly because in the third case, we want numbers that are divisible by both 3 and 5 print this bus, and I kind of mentioned it just now. We need to always handle the more specific kind of condition first. So in this case, we want to do element divided by 3, divisible by 3, and element divisible by 5. Now we want to print both fizz and buzz. Alright. Yep. Now it works. Oh no, it doesn't. Because this needs to be in else if. Otherwise, if I don't do else if, this is treated as two different checks. So in this purpose, we want to be in one big check that covers all the numbers. Yep. And this passes the requirements. And if you read the question correctly, you might have missed another problem because I told you range only gives me a range of number up to the number before 50, right? So what we can do here is, because another problem with this is that it started from 0, right? While the programmers always count things from 0, but in real life, people still count from 1. So what we do here is, remember to do a +1 whenever we refer to element. There we have it. So this is an example of a real world, not really real world, it's a quiz programming puzzle. Hopefully you find this useful lah. So this kind of concludes the whole session. Any more questions on this?
Yeah, like when you use poetry in the beginning just now, when you want to initiate Rato, why is it that you use poetry new and then there's the argument _src? What does that mean?
_rc is just that you will have this folder created src. This is a personal preference because when you write a larger program, it's always better to have a folder that kind of describe what it contains. Because if you don't, this folder will be named tutorial. I can show you the content of src. So this folder will be placed inside here instead of src. the reason why this is helpful is because sometimes I will probably write another library that is called a tutorial tool, for instance. PSRC tool. Then inside my code, I will be referring that yeah, it might not seem very intuitive to you. You can actually get this to work without the double dash SRC flag, but yeah, it's just a personal preference. You can always start a new poetry project without the double dash SRC. It's not a big deal. And the reason we use poetry is because we want to initialize a contained environment. You can see it here. So we have a contained environment set up here. So whatever things that you imported to libraries that you imported, very, or probably you wrote some program that affects other, that potentially that can affect other libraries changes, or you make changes to other people's library or stuff. It will be all be contained within just your project, because this is created for every project. A new contained environment is created for every new project in as long as it's managed by Poetry. So, yep. Any more questions before we end this session? Yeah.
Can we do like poetry Python pip install? Is that possible or not?
Yeah, you might have heard pip install somewhere. Yes, you can do pip install here, but it's not called pip. It's because as we use Poetry here, and contained environment is being set here. So if you want to import a library, we will do Poetry add the name of the library here.
Oh, okay.
So instead of issuing a pip, you do this. You can also do a pip install here, but because usually when we use Poetry, we write a project. What it does is that besides calling, this is actually pip, right? This is actually pip. But however, yeah, what pip doesn't do is that it doesn't populate this one. It doesn't populate the project file. So if you happen to build your project to distribute it for other people to use, yeah, if you do a pip instead, it will not be populated here. So whenever you package your project, the same setup will not be reproducible on other people's computer, other people's setup. So this is the reason why we use Poetry to manage our project, because we want the users of the project we publish to be able to replicate the setup. Yes, you can do a pip here. You can do a Poetry run pip. You see what pip is there? It's just that if you do it this way, the libraries that you installed will not be, the name of the library that you installed will not be populated inside the project file. Yep. Any more questions? If no more questions, then I shall end this session lah.
Okay. Thank you very much.
No worries. Bye bye.
Bye bye.